So one of the last parts we need to do with our data sheet is these qualitative check boxes at the bottom. The first one is the water appearance. Your choices are scum, foam, muddy, milky, clear, an oily sheen, or brownish. For today, I would say we are clear. I noticed when we were taking up our samples in our container that they were all clear looking. If there's foam, sometimes that can be natural or human influenced. If it's a human produced foam from like phosphates, they will tend to be more white and pillowy. If there's an oily sheen, that might be oil is on the surface. Sometimes some bacteria can produce that oily sheen as well. Our next checkbox is stream bed coating. Our choices are orange to red, or yellowish, black, brown, or none. And so we're looking to see if there's any kind of coating on our, like a good example is on our rocks here. We do have a lot of sediment that's come down, and we have some like detritus matter that's a little bit kind of like peat-like that's settled off on the stream banks here. So what I like to do is I kind of sometimes take my finger and rub my hand against the rock and see if there's any kind of that coating that comes off. And I'm not really seeing any coating, so I'm going to put none. My last check box is odor. My choices are rotten egg, musky, acrid, chlorine, or none. So just using your nose. Not smelling any. Sometimes a musky or an acrid could be vegetation that's decomposing. If you get a like a sulfur smell, that's like a rotten egg. Sometimes there's like sulfur that can be coming up through your groundwater. If you get like a waste or a like poop kind of smell, sometimes that could be that there is a septic tank that hasn't been operating correctly, so that might be an indication of that. So those are all three of those check boxes at the bottom. If none of those choices fit, there are options to put other in. So one of the last pieces to do to fill out the data sheet is to calculate the percent DO. And this is looking at the relationship between water temperature and your dissolved oxygen. It just gives it in the percent form versus milligrams per liter. And so we have this chart in the binders, and it gives on the top scale the water temperature, and then on the bottom is your milligrams per liter for your dissolved oxygen, and then the diagonal scale converts that to percent DO. So what you do is you just take those two numbers that you've already calculated, and you have a ruler, and that's going to help you determine kind of that cross angle of those two. So you want to refer to your data sheet. So for our water temperature, we had 15.8, and for our dissolved oxygen, we had 10.5. And you might have to adjust both sides to make sure you're in the right. So 15.8. and then 10.5 for our dissolved oxygen. Alright, and so I like to a lot of times use the pencil to kind of mark my point and then move the ruler away. And so you can see that I am at 105% DO, percent dissolved oxygen, and that's what I write down. And so usually we're looking at 90 or above is generally good, especially with our creek water being kind of a higher temperature. We're still reading a pretty good dissolved oxygen percent saturation.